So today we're going to talk about something called regression. And today we're going to focus specifically on polynomial regression, but you can in fact do a regression on any type of data that fits a specific model, or where a specific type of function, rather, can model it. Okay? So we are, in fact, going to also do regression when we look at sinusoidal functions as well, which are trigonometric functions. Okay? But today we are just going to look at polynomial regression. Okay? Now, what is regression? Well, it all starts from this, which is a scatter plot. And I'm going to assume, correct me if I'm wrong, please, that at some point in your lives, when you think back from kindergarten to grade 12, you've made a scatter plot and you've drawn in a line of best fit. Is that good? Correct assumption? Okay, so that's kind of what you see here, right? Usually when you're doing an experiment, maybe in science class, and you have all this data, and you can see that there's a particular trend, and then you kind of like put your ruler up and you try and fit the line in so that it hits the most number of points as possible. Okay? So regression is just when we use technology to do the same thing. Okay? But when we're doing performing a regression on a set of data, then we are not limited to linear data, which is probably what you've done up to this point, where you make a line. Okay? If something looks like it's forming a parabolic curve, if the data looks like it's parabolic, you can do something called a quadratic regression on that. And your calculator will actually, if you give the calculator the data, will give you the line of best fit, an equation for the line of best fit, or an equation for the curve of best fit. It's pretty cool, actually. Okay? So this, for example, is just a scatter plot as an example of that compares your income. This is probably, I'm assuming, it's either hourly or it could also be in tens of thousands of dollars per year, possibly, compared to your years of experience, right? So the general trend is that the more experienced you are, the higher your salary or your income. Okay? And it looks like that forms a rather linear path. Okay? Now, interpolation is essentially when we make a prediction about an unknown data value within the domain of the data. So as an example here, okay, we have years of experience anywhere. Our last point happens at 35 years, from 0 years to 35 years. If I wanted to know, for example, how much are you going to get paid with 2 years of experience? Okay. 2 years of experience, we don't actually have a data point there. But if we draw a line of best fit and we say, okay, that's about 2. So it's going to be, I don't know, maybe, let's say this is dollars per hour. Okay? That's, I don't know, like maybe $28 per hour. That's called interpolation. Okay? So this is when we predict a value within the domain of the data. In this case, the domain of the data is points between 0 years and 35 years, because 35 is our last data point. And you can see this isn't perfect. It looks like in this example, if we're looking at just a small group of people, the person who has 30 years experience makes a little more than the person who has 35 years of experience, but in general, there's an upward trend. Okay? So that would be like, for example, 2 years experience, $28 per hour. Okay? Extrapolation is when we make a prediction about a value beyond the domain of the data. Okay, so if I go back up to this graph, if I wanted to know how much would you make per hour after 45 years of experience? That's about what? 82? No. Oh, these go up by 10. So that's about, I don't know, $83 per hour? Okay. And of course, this isn't perfect. We also have to understand that sometimes certain applications are going to flatten out, right? So a really good example of that is if you look at a person's height between 0 and 5 years, you can't use that to predict how tall they're going to be when they're 60. Why would that be a bad extrapolation to make? Yeah? Yeah. You stop growing. Yeah, let's not talk about that yet. But yes, you stop growing when you're depending on your genetics and your gender, I don't know, somewhere between like 17 and 25 or something. And then, yeah, when you're old, hopefully after 60, but I suppose it could happen before that, you actually start to shrink, right? So that actually is, your height is a combination of a few linear functions. It's upward slope, and then it's a flat slope, slope of 0 for a long time, and then it goes a little bit downwards, right? So yeah, you have to know a little bit about the situation as well. But we can use this, and in fact, this is what scientists do all the time. They gather data, they try and generalize it. The process of generalization is when we can, it's called math modeling, actually, when we can find a math equation to represent the data and any sort of pattern that we see happening in the data. And then we use that data to make predictions, to make decisions for all sorts of reasons. Okay? So how do we do this? Take out your graphing calculators. The first thing that we need to do is to enter the data that we have into our graphing calculators. And you're going to enter the data into a couple of lists. So the thing that's important to remember is that just like a table of values, x goes on the left, y goes on the right, your independent variable, what would be on the horizontal, should go on the left, which is usually L1 or list 1, and the dependent goes on the right. Okay? Now, let's look at an example. So I talked about, I have a page on this on how to enter data to determine a regression, but I kind of stopped filling that out because I think what I've done before, and I'll link to this in my post today because I forgot to do so, I have some instructions like on a PDF for each type of calculator, and then I'm looking up things, going back and watching the video or that kind of thing. But the best thing you can do today is to actually have your calculator out and do it with me. Okay. Just going to make this a little bigger. Okay, so we're going to actually turn over here. Okay, so example. The 1 hour record is the farthest distance traveled by bicycle in 1 hour. The table below shows the world record distances and the dates they were accomplished. Okay, so you can see like in 1996, the 1 hour record, which is how far you go in 1 hour, was 78.04 kilometers. That's crazy fast. Okay? And then in, I don't know, 2007, it's 86.77 kilometers, that sort of thing. Okay? Now, sometimes your table of values are organized vertically, and usually it's pretty easy to tell what's independent and what's dependent in that case. This is like a horizontal table, and you see those sometimes. Which variable is independent here? Yeah, the years. Time is always independent because we can't control it, right? And if you're ever unsure of what's independent, say these two things, ask yourself what makes more sense. The distance someone bikes depends on the year, or the year depends on the distance someone bikes, right? It's not like if it's 2020, everyone can bike at 100 kilometers an hour, right? It doesn't work that way, okay? And what we can see is that it tends to be an upward trend, right? So it looks like as the years go on, the record keeps getting beaten and beaten and beaten, okay? And that tends to happen in sports. I think it's actually a lot of it comes to science. And now we're actually using researchers and scientists to figure out what the best type of training is, right? And so people do get better and better and better, okay? All right, so this is independent. And this is dependent, okay? So if you have a TI, I'm going to do that first, I think, because I think most people have that. What you're going to do is go to your stat button. It stands for statistics. And click number 1 for edit, because we're going to edit some values here. So go enter. And here you see that L1, L2. Okay? So, yep.
Sorry, where's the stat button?
The stat button is right here, a couple away from the alpha. And I can't ever remember these, so I'm going to actually try and do this. Have them both on there at the same time. Okay, so under L1, I'm going to enter in all of the years. 1996, and you can just hit enter, and it goes down to the next line. 1998. I have a call coming in, guys, and I'm sorry. I feel like I have to take this. I'm just going to pause this. $1999, 2002, 2003, 2004, 2007, 2008, and 2009. Why do you think some years were skipped? Yeah, there was no new record that year. Exactly. Okay? And then you can hit your right arrow, and it'll go over to the top of the next list. Okay? So now I'm going to put in my distance. So 78.04, 79.14, 81.16, 82.60, 83.72, 84.22, 86.77, 87.12, and 90.60. Okay? So I've got all that in there. Now on the Casio, go to your menu button and select statistics and go enter. And you'll see those lists pop up there. Okay? So I'm going to enter them again quickly. Okay, and then over to this side, 78.04, 79.14, 81.16. I talk to myself a lot. Okay, there we go. We got all the data in there. Okay? Now, on the TI, you're going to go back to stat. Well, actually, before we do that, forget that. Okay? Before we do that, let's say we want to look at this data. Okay? So what I want you to do is go to y equals and erase anything that's in there. If you're like me, you probably have unless you did your homework, you have the function from Friday. And then what I want you to do is go up to plot 1. This turns on a scatter plot, and hit enter. Okay, and when it's highlighted like that, it means your scatter plot is on. Okay? Now, if we hit graph right now, we're not going to see anything because, oh, maybe. But if you have zoom standard, right, you're not going to see anything because none of my x values were from -10 to 10. None of my y values were from -10 to 10. Okay? So you can either change that manually to set your data, Or there is a built-in setting. If you go to Zoom and then hit Stat, number 9. On some of the calculators, you have to scroll down to 9. It's not in your window right now. But if you hit number 9, Zoom Stat, then you should be able to see those points. Your scatter plot has to be turned on. Okay? Now, one of the reasons why it's nice to do this sort of thing, and by the way, on the other calculator, if you want to do that, you just hit F1 for graph. And I believe F1 again. And the nice thing about this calculator is that it sets your window settings for you, so you don't actually have to worry about that. Okay? All right, so back to here. And, well, either one, it doesn't matter. One reason why it's nice to look at your points first is sometimes you actually have to decide what type of regression you're going to perform. So you want to know, does this look like a line? Does it look like a parabola, right? Does it look like a cubic thing where it goes, there's a couple of bumps in the data? Or perhaps when we get into this, it might look like a wave, which is a trigonometric function. Okay? So one of the reasons why it's nice to look at this is just to say, okay, this looks like a line. I got to do a linear regression. Okay? So how are we going to do that? You're going to go back to Stat. This time, we want to calculate. So I'm going to go to the right and hit Calc. And on this screen, you have a bunch of options. Okay? The ones that we are going to use at this time are number 4, number 5, and number 6, because we're just focusing on polynomial functions. So we might perform a linear regression, a quadratic regression, or a cubic regression. Okay? By the end of the course, we'll actually learn 3 more. We're going to learn a logarithmic regression, an exponential regression, and a sinusoidal regression. The hardest is the first day, though, because the process is the same, except which number you select. Okay? So we want to select number 4. So I'm going to hit number 4. And on some calculators, you will see this screen. On some calculators, you just see linear regression. Okay? If you just see linear regression, you can hit Enter. If this is what you see, you're going to scroll down to Calculate and then hit Enter. And what we are told is that the equation of the best fit line takes the form y equals ax plus b, where a is 0.8584, et cetera, and b is negative 1,635.32, et cetera. Okay? So what we can do is you could write down all these values, and you could enter them into your y1 equals, and you'll get the line of best fit on that. Okay? But there must be a better way, and in fact there is. There's a way to tell the calculator to kind of copy and paste. Okay? And so I want to show you how to do that as well. So I'm going to clear this. I'm going to do that whole thing again where I hit Stat, go over to Calculate, and I'm going to go to number 4 again. And what I can do is on this line where it says Store Regression Equation, I can say, I want you to store that equation in y1. So I am going to put a y1 right there. Now, getting to the y1 is, a bit of a journey. But essentially, if we put a y1 in here, it'll copy and paste, which is really nice. Okay? How do we get there? We hit Variables, this button, vars, or variables. Okay, so hit that guy. We want the y variables. So go over to the y variables. Go over to the right. We are looking at a function here. Okay, parametric equations and polar equations are way beyond the scope of this course. So we'll always hit number 1. And then you can select wherever you want to store it. So I'm going to hit number 1 again. Okay? And then if I go down to Calculate and hit Enter, shows me the same thing. But if I go to y equals now, it's copied and pasted that in there. Okay? Which is nice because not so much for linear equations, but for most of the rest of them, if you round, it actually changes the value of the function quite significantly. Okay, so it's actually quite important to keep most of these, or all of these decimal places. Now, if you don't remember how to do that, you always have the backup of writing down your A value, writing down your B value, and entering it manually. Okay, so, and if I hit graph now, you can see there's the line of best fit. Okay, now, on the Casios, okay, before we hit graph, right, that's when we saw our scatter plot, you can go to F2 for calculate. And now you have an option, and you're going to select regression, F3. And you have all of these different options, okay? Now, for this unit, which is just polynomial, your linear is x, your quadratic is x squared, your cubic is x cubed. Okay? So I'm going to select F1 for linear. And you can decide whether you want the constant first or the slope first. I always pick ax plus b because I'm used to writing it as y equals mx plus b. So I always select F1. Okay? And then here is your equation. It's the exact same thing. If you want to copy it, you hit F6, and it copies it, and then you hit enter, I believe. And there you go. It copies and pastes it right in there. Okay? And then if you hit enter, whoops. Oh, no, sorry, okay. I always forget this. When you want to graph on a Casio, you actually have to go back to menu and then go down to graph and select that. Okay? And then hit enter. Oh, wait. Exit. Select F1. Enter. And there you go. Okay? The scatter plot is not that important. So because the fact that you don't see the points doesn't really matter. We're more concerned about the line of best fit. And that's how you do it. All right? And if you do this 4 or 5 times, you'll just remember where to access all of the right buttons. Okay? But you have to practice. People will do a quiz without practicing regression, and that regression question may be out of 5 marks, and you get 0 because you've never practiced it before. Okay? So just hint, hint. All right, now let's answer some questions about this. Okay, so first thing that we want to do is determine the linear regression equation, rounding values a and b to the nearest hundredth. Okay, so linear regression equation. We can copy that right out of the calculator. In fact, I should. Oh, no, it went away. But if I go back to y equals, I can see it, right? So to the nearest hundredth, the a value is 0.86. And the b value is negative 1,635.73. So if I'm copying that in, my equation should be y equals 0.86x minus 1,635, was it? I think. Let me double check that. Is that right? Okay, sweet. I have the worst memory. Apparently, you're supposed to be able to remember 7 numbers in a row, and that's how they decided to make phone numbers 7 digits without the area code, because humans can handle, in their short-term memory, 7 numbers. Apparently, I can't. Okay, now, some pitfalls. This will get you full marks. Here's what won't get you full marks. So this is good. Okay, don't do this. One thing that I see a lot is just writing 0.86x minus 1,635.73. Okay? This is not an equation. No equal sign. A regression equation should have an equal sign and two variables in it. Okay, this is not an equation. I'm being ambitious here. I can't write all of that on there. Okay, here's another thing that I don't want you to do. I don't want you to write A equals 0.86, B equals negative 1,635.73. This is also not an equation. Okay, so you have to write it in the format of a standard linear equation. Okay, so that's just the first step. Now we're going to do the interpolation and extrapolation, which is we're going to use this data and the linear regression function to determine information about the situation. Okay, so interpolate a possible world record distance for the year 2006 to the nearest hundredth of a kilometer. Okay, so what happens with a lot of these questions is you get the equation, then they give you an x value, you have to find the y value. Or they give you a y value, you got to find the x value. And that tends to be the pattern that happens. So really what you have to do here is figure out, okay, we know one of the variables, one of them is 2006. Is that x or is that y? X, right. Okay, so this means x equals 2006. We want to know what y equals. Okay, now you could plug 2006 right into that equation over there, but you're going to be off a little bit because that was rounded. Okay, so if we use this rounded equation, right, and we go y equals 0.86 times 2006 minus 1,635.73. And that is, I don't know, what is that? I gave my calculator away. It's okay, I have another one. Okay, 0.86 times 2006 minus 1,635.73. That is 89.43. Kilometers. Okay? Now, this is rounded. If you want to be more precise, use technology. Okay? So on a TI, how do you do that? Well, yeah, you go to graph, second, trace, and the number one value allows you to enter whatever x value you want, and the calculator will give you the y value. So hit number 1, and then just enter in 2006. And you get 86.38. Is that right? Yeah. 86.38? That seems really far off. Hold on a second. Did I copy this correctly? Yeah. Oh, you know why? Here's why. You're multiplying 0.86 by 2,000 something. Okay? If you round the slope and your x value is quite small, it's not going to make a big difference. But if you round the slope and your x value is very, very large, and you're multiplying that by something in the thousands, your answer is actually going to be a few kilometers off. Okay, so it's better to use technology. Okay, so using technology, it's 86.38. That makes sense that it's under because that slope value, we rounded up. Right? Okay, 86.38. That's quite significant. Right? Now, on a Casio, Okay. Once you have that, go to G-solve and select more. So go to F5. And we want to do a y calculation. We know what the x value is. We want to know what y is. So select F1, put in 2006. And there you have it. Same thing. Okay? So here's where we talk about rounding. I would prefer that you do this. Okay? On a diploma exam, if this was a a written response question, and you made a rounding error in a written response question and everything else was correct, how much do you think they take off? Let's say the question's out of 3. What do you think they take off for rounding? 1? 2? Half? 0. They take off nothing. Yeah. However, numeric response is ruthless. Ruthless. Okay? So if they ask you to use technology to figure this out, and technology on numeric response, there'd be too many digits here to put it in anyway. But if they ask you to round to the nearest 10th or whatever, right? You make a rounding error, you get nothing. And if there's 10 numeric response questions on your diploma exam, that's a significant portion of your mark. Okay? So when I mark, I'm consistent. I'm ruthless with rounding. That's where they actually assess rounding on a diploma exam, is through numeric response. Okay, and actually I remember last semester in one of my 10C courses, I had several people on their numeric response, I think it was a linear functions test, who got 0 out of 6, and every single mistake was rounding. Yeah, so you have to develop some strategies, and we'll talk about that, so that you can double check, because that hurts, right? You don't want to lose marks over there. Okay, so C. Compare your estimate with the actual world record distance of 85.99 kilometers in 2006. Yep. Question?
Last question.
Yeah.
Full marks, we just write y equals 86.38.
Yeah. If it was, okay, so what I would probably ask you to do if this was written response is ask you to sketch it for me, right? Okay. Compare your estimate with the actual world record distance of 85.99 kilometers in 2006. Okay, so the estimate is a little bit high. It's pretty close, but a little bit high. It's, I think, 0.39 kilometers higher. Right? Now, why does this occur? Because we are making a generalization from actual data, okay? And what happens in real life and what happens theoretically are often quite close but not exact, right? So the theoretical value doesn't usually match the actual exactly. Exactly. There we go. Okay? All right. You ready to do another one? Okay. So the concentration in milligrams per liter of a medication in a patient's blood is measured as time passes. Heather has collected the following data and is attempting to express the concentration as a polynomial function of time. Okay, so here is the data. So if you can imagine what's happening, let's just think about this a little bit. As soon as the needle goes into their arm, well, actually, let's pretend even that they're swallowing this, because that would take a little bit more time. As soon as it goes down your throat, what's the concentration in your blood of this medication? Nothing. Right. And then as time goes by, do you go up to the full concentration immediately? No, it kind of happens gradually, right? Think about ever, like, I don't know, having a sore, well, you guys don't have this yet, but if you have a sore back, take some Tylenol. It takes like half an hour to start feeling the effect. And then what happens after a certain period of time? What happens 4 hours later? Yeah, you need more Tylenol because it's wearing off, right? So if you can look at this data, you can see from 0 to 4 hours, the concentration is increasing. And then it starts to decrease. Okay, so think about this. Data's increasing, and then it decreases. What type of polynomial function do you think we should use to model this? What is that? Yeah, quadratic, exactly. It's a parabola, right? So what regression model best represents this data? Quadratic, right? And why? The concentration is increasing for 4 hours, then starts to decrease, right, as the medication is wearing off, okay? Now, we need the equation, so let's go ahead and take out our calculators again, and I'm going to go to stat again, because now I want to enter in new data, right? So I need to edit my lists, okay? Now, there is a way to erase the entire thing at the same time. You're going to go up to L1. Do not hit delete, because that deletes the whole list, and then you just have starts at L2. But if you hit the clear button and then hit enter, it erases everything. Okay, so I'll do that. Clear, enter, there we go. Okay, and it looks like my time values go from 0 to 6. So 0, 1, 2, 3, 4, 5, 6. And then over to L2, my concentration values are 0, 24.7, 36.8, 44.2. So you guys do this with me, 47.5, 43.8, 37.1. I'm going to do it on the other calculator as well. Okay, so to do it on the other calculator, I'm going to go back to menu, back to statistics. And then again, you can highlight L1. And, oh wait, just go exit. Delete all. There you go. You have to go over to the right, delete all. F1, there you go. Okay, so it's the same idea. There's an easy way of doing it. Delete all. There we go. Okay, so I'm going to enter these again. Okay, and 0. Oh, I can't remember what they are. 24.7, 36.8, 44.2, 47.5, 43.8, 37.1. Okay? Now, if you want to see what this looks like on the Casio, again, the scatter plot, you just hit F1 for graph and graph 1, and there you go. And you can see it's parabolic. Okay? On the TI, our scatter plot should still be turned on. So if you go to y equals, this should still be highlighted. We don't really want to see this, though, so clear that out the way. And then you have to reset your window again, because the window setting was from the previous regression. So go to zoom and hit number 9 again, zoom stat. And there we go. Okay? All right, so we want to do the regression. We are going to, on this calculator, go back to stat and go over to the right for calculate. And this time, I want to do a quadratic regression. So that is number 5. Okay, and again, I want to store the regression equation. Oh, I forgot to mention this. If you have an older calculator that doesn't have this menu and it just says quadratic regression or whatever, before you hit enter, you can just put y1. So just go through that process of figuring out how to enter y1, hit the y1, hit enter, it'll store it in there for you. And I will come around when you guys are practicing and troubleshoot for you as well. But I'm going to go to store regression equation. And to get that y1, I'm going to go to variables and over to y variables, and number 1 for function and number 1 for y1. And then I'm going to go down. Or if you have the older one and it just says quadratic regression, you can just hit enter at this point. Okay, and there is our regression equation. So when we're writing out what the equation is, here we can round. Okay, so in this case, we are rounding to the nearest hundredth, again, 2 decimal places. So remember a quadratic equation format y equals ax squared plus bx plus c. So you need to put it into that format and replace a, b, and c with those values. And the values are, I'm never going to remember this. Y equals negative 2.91x. Okay, let's start with that. And then, what's b, guys? Help me out here. Squared, yes, thank you. 23.16x, you're right. Should be x squared plus 23.61x. Shoot, was that right? I can't remember. No, 16, plus 1.74. Okay, I can fix that. Plus 1.74. Okay, so there we go. On the other calculator, here it is. Again, you are going to go back to back to that list and hit exit because we want to get back to this menu. And then you go to F2 where you can calculate. And this time, again, a regression. You want to select F3 for x squared. That's a quadratic regression. And there it is. Same values. We can copy it and hit enter, and then hit copy again, and it puts it right in there. Okay, and then remember on these guys, if you want to actually graph that, you have to go back to menu and select graph. And then you can see what it looks like. Okay? All right, questions on, hold on. Do we have, yes, good, okay. So first question about this one is what is the domain of this function? What's the domain? So we have to think. So you might think it's 0 to 6, but we're really looking at the domain of a regression function. We only have a couple of data points here. So what's actually going to happen, right, is that when time is 0, the amount of medication in the person's blood is 0, and then kind of goes up, and then it starts going down. Now, we only have up to 6 hours, which is sort of on the downswing, but it'll keep going down until it hits that X-intercept. Till the the concentration of medication in your blood goes back to 0. So we got to figure that out to determine the domain. Okay. Now here's where that built-in window setting has its limits, because the built-in window setting matches the data in your lists. But if you want to extrapolate, you have to play with the window settings a little bit so you can see what you need to see. Okay, and that's on both calculators. We've done that a lot, though. So if I go to y equals, it should be in there. I'm going to hit graph, and you can see it cuts out, right? So I need essentially to make my x max bigger so that I can see more time on this side. So I'm going to go to window, and maybe I'll make this 10. Okay? And then I'm going to hit graph. And now I can see that point right there. Okay? So to find that point, I'm going to go second calc. And that is an x-intercept also called a 0. So I'm going to hit number 2. And I'm going to go to the left of it. And I'm going to go to the right of it, down a little bit. And I'm going to hit enter. And I can see that that's x equals 8.04 hours. By the way, I'm glad that this came up. Do you guys know what this means? Negative 4e, negative 12? Yeah, it's scientific notation. So the calculator isn't perfect. But this is essentially negative 4 times 10 to the negative 12, which is basically 0. Okay? So when you see that, it's just 0. Okay? So 8.04 hours. So the domain of this function is 0 hours is less than or equal to x, which is less than or equal to 8.04 hours. Okay, so you may want to put that in here. This is 0. This is 8.04. We need this point, because that's when there's no medication left. Okay, one more question on this one. Okay. The doctor has decided that the patient needs a second dose of medication when the concentration in the blood is less than 10 milligrams per liter. If the first dose of medication was given at 9 a.m., at what time should the second dose be given? Okay, so here's what's going on, right? They need to top you up at a certain time. Once it starts to go too low, they're going to top you up with another dose. So if we look at this function, right, the top was somewhere around 40-something. So this is in the 40s. Once the concentration is less than 10, we're going to give another dose. So that concentration, that means that we know one of the variables. One of the variables is 10. Which variable do we know? X or Y? Y, exactly. So what we want to know is y equals 10, x equals what? And I find doing this kind of analysis really helpful, because it makes it crystal clear what I'm trying to find. Okay? Now, y equals 10 is along the vertical. So that's along here somewhere. And actually, it's going to hit the graph twice. Oh, that's not a very good horizontal line. Hits it here and here. Which time are we interested in? The second one. Yeah, you don't want to give them another dose when the concentration is rising. You want to give it to them when they're falling. So essentially, we want to know, what is this x value? Okay. Now, on the TI, if you know the y value and you want an x value, you have to graph a horizontal line and then find an intersection point. So we're going to graph a horizontal line at y equals 10. I'm going to go back to y equals. I'm going to go down to y2. And I'm going to graph that horizontal line. What's that? Oh, I think it was someone outside. All right, there we go. And this is the value that we're interested in. So to get that, again, everything's under second trace. And now we want number 5 for intersect. Okay? And we're going to go close to it on one. Doesn't have to be super close. And the other. And we see that x equals 6.594. 7, thank you, 0.594. Okay. So this is the point 7.594, 10. Okay. On the other calculator, by the way, because I know some of you guys have this one. Okay. Oh, right, I have to go back to menu. I always forget to do that. Go down to graph, enter, select that, so F1, enter, there it is. Okay, actually, I do need to make my window a little bigger here too to be able to see that 10 on the other side. So I'll go to my window, and I'm going to make the x max 10. Draw, and there we go. Okay. Now, on this one, you don't have to graph a horizontal line. You can go to gsolve and go over to the right. This time, we want to know an x value. So we're going to hit xcalc. And we can enter in y equals 10. And it'll give us the first one first. You just go over to the right, and it gives you the second one. Okay? So that's how you do it on that calculator. Same idea, though. Okay, now, we haven't quite answered the question yet, though, because we are asked, the first dose is given at 9 a.m. What time should we give the second dose? Okay, so we need to know what is the time 7.594 hours after 9 a.m. Okay, well, hopefully the 7 hours piece is okay, right? So 7 hours is like, okay, 10 a.m. would be 1 hour, 11, 12, 1, 2, 3, 4. So it's going to be 4 something in the afternoon. Does that make sense? What we need to figure out is 0.594 hours, how many minutes is that? Yeah. 35.4, how'd you get that? Right, because there's 60 minutes in an hour. If you remember all the way back from grade 10, comes unit analysis. We multiply 60 minutes per 1 hour. You don't need to know this, but I'm just showing you why it makes sense. The hours cancel, and you're left with minutes. Oh, I'm going to put 594, sorry. And that was 35 point what? 0.4 minutes. So I, in this case, would probably just round to the nearest minute. And I would say it is 4:35 p.m. Okay? All right, questions with that? Okay, so I want you guys to try these practice questions in class. There are 2 of them, I believe. 1, 2, oh, maybe 3? There's 2 of them. So we have quite a bit of time. I want you to get that down. Make sure you know what you need to do on your calculator. And then your homework for today is on the board.